Okay, welcome to section 2.1. We're going to be solving linear equations. So looking at a little vocabulary here, a solution of an equation is a value of a variable that makes a true statement when substituted into the equation. Again, calculator checking here for your work, so everything still is going to be gradable. A linear equation is an equation in one variable that can be written where a and b are real numbers and a is not equal to 0. So the concept here is we're going to have a lot of variable x's to the first power. We're going to be combining like terms, and eventually you want to isolate the variable term to one side, the constants to the other, and we're going to solve. So our strategy for that, here we go. Number one is simplify each side of the equation as much as possible. So like I said, we'll do some combining of like terms. Sometimes we will use the distributive property to remove parentheses, and sometimes we won't do the distributive property. Again, we're going to make you as efficient as possible. And if you have to do the distributive property, that means you traditionally make the values much bigger and more difficult to work with. Well, there's some other things you can do to make values smaller. All right, step 2, we're going to collect all the variable terms to one side of the equation. We're going to use the addition or subtraction property of equality, which means if you add the opposite of a variable term, you will cancel it out to a 0 on one side, and it's moved over to the other side. We will also do that with our constant terms, same property, addition and subtraction property of equality. Then we're going to make the coefficient on the variable equal to 1, which means we will use the multiplication or division property of equality to undo the multiplication or division that's happening to the variable. Then we're going to check our solution, and no, we are not going to substitute the solution into the original equation. We're going to use our calculator. All right, so again, some tidbits here. One thing I want you to add into these steps here: move the smallest variable term. What this does is that it guarantees you that your variable term is going to be positive when you solve it. That way we avoid any negative sign issues. The next thing I want you to understand in terms of the solving is that we got done talking about the order of operations. Please excuse my dear Aunt Sally. And when you simplify, you start top down. But when you solve, you start at the bottom and you undo everything you see going up. So it's predominantly, we're going to undo what you see. If you see adding, you're going to subtract. If you see subtract, you're going to add. If you see multiply, you divide. If you see divide, you're going to multiply. All right. So again, this is this concept here of using the addition or subtraction property is the undoing process. All right, so let's look at some examples here. Very straightforward. Here we have x plus 7 is equal to 2. What we need to do is get this x by itself, so we're going to take this plus 7 and say, okay, I want to do the opposite of adding, which is subtract 7 from both sides. So as long as you put minus 7 equals minus 7, this is the subtraction property of equality. It's like thinking of this as a balance scale. I take 7 pounds off of one side, 7 pounds off the other. It stays balanced. So 7 and minus 7 cancel. X is equal to a negative 5, and we're done. Number 2, 17 is equal to x minus 43. Here's my x. It's positive. We need to get rid of the minus 43, so we're going to add 43 to both sides. Again, notice my equal sign is lined up. Cancels on the right. 17 plus 43 is 60. There's my answer for x. Fraction work, x plus 3/4 equals 7/8. I need to subtract over 3/4, but they're not common denominators, so if you want, we can say 4 goes into 8 twice. We'll make it a common denominator, so when we subtract over the 6/8, x is equal to 1/8. You can move over the 3/4 and then change the denominators, or you can do it first. Either one is fine. Just make sure you show the work. Number 4, here we have negative 6 times x equals 54. So I need to undo the multiplication of a negative 6. So that means to divide both sides by a negative 6. And we traditionally use the fraction bar to show our division. So cancels the negative 6's. We get x equals 54 divided by negative 6. X is equal to negative 9. Number 5, x divided by 7 is equal to 12. Okay. To undo division, you have to multiply 7 to both sides. Well, that will cancel on the left side. X will equal 12 times 7, which is 84. Number 6, we have x divided by 4 on the right side. It's positive, so we'll just multiply 4 to both sides. 4's cancel. And 4 and 6 can reduce. We'll have a 2 and a 3. Negative 7 times 2 is negative 14 over 3. There's my final answer. Number 7, here we have both multiplication and division going on. Well, what we can do is we can take care of this all at once. Remember, we talked about reciprocals, and when you multiply reciprocals together, they cancel and reduce to a 1. So if I flip 7 ninths to 9 sevenths and multiply that to both sides, those will all cancel, leaving me an x. 7 goes into 21 3 times. 3 times 9 is 27. There's my answer. So same thing here with number 8, multiplying by 5/8. We're going to multiply by the reciprocal 8/5. Cancel that out. And let's see, 4 can go into 8 twice, so we have negative 6 over 5 for an answer. Now, I did promise that we are going to go back and check this, but I want to use some problems that are just a little bit longer than these. These are pretty straightforward. We might bring the calculator out for these. All right, so number 9, we have 4y minus 7 is equal to 11. So there's only one y term that's over here on the left, so everything on the left has to move to the right. So starting at the bottom of your orders of operation, there's a minus sign. You have to get rid of that. Add the 7 to both sides. 4y is now equal to 18. Then we divide by 4. We're going to reduce this, and we're going to get 9 halves. There's my final answer. So if I brought the calculator over into play, let's see, get back to the home screen here. All right. Now, what we will do is you need to store the answer that you came up with. All right, so I'm going to go alpha y equals to get my fraction bar, so 9 over 2. We are going to store that, and I'm just going to store it for x, as I just change all my variables to an x. Okay. All right, so now here's what we do. We go back to the original problem, and we're going to type in the left-hand side, 4x minus 7. Now, if my answer is correct, my calculator will tell me that I have 11. I have 11, so now I know I'm right. So that's how we're going to grade it. All right, we'll come back to number 11 because there's 2 x's there, and we'll show you what we do there. Okay, number 10. So again, negative 8a plus 12 is equal to 38. A is over here on the left side, so let's get rid of the 12. We're going to subtract the 12 over. That cancels out. 38 minus 12 is going to give me 26. Next, multiplication of negative 8. We need to get rid of that. So to undo that, we're going to divide by negative 8. So reduce 26 over 8 to be 13 over 4. My answer is negative 13/4. So again, store that for x or whatever variable you want to use. Type in the left side, make sure it's equal to 38. Now here, number 11, we have 2 variables, one on each side. The rule here that I like to use is always, always move the smallest variable term. Well, negative 7 is smaller than 3. So add the 7x to the other side. Notice that this is now a positive x term. And we have to divide both sides by 10. So x works out to be negative 3. Now, how do you check this one in your calculator? Well, x was negative 3. I have to store that. Negative 3, store it for x. Now, to verify my calculator that it's right, I type in the original left-hand side. Negative 7x minus 30. Enter. That's this answer. Now I type in the right-hand side, 3x. And if this is going to be correct, both these numbers have to be the same. Since they are, I now know that this answer is correct. Everything is going well so far. Okay, 12. Here's an example. We have 6y plus 8 minus 5y. We have two y terms. We must combine these together. And since they're on the same side, just use the same signs. 6y minus 5y is going to be 1y plus 8 equals negative 7. Subtract over the 8. Y is equal to negative 15. So again, store negative 15 for x or for y. Type in the left side. If it equals negative 7, you're correct. 13. Now, 13 and 14 is really good examples on that distributive property concept. When do I have to distribute and when I don't have to distribute? So here I have 9 times x minus 2 plus an 11 minus an 8x. So since I have x terms here on the inside of the parentheses and on the outside, I have to distribute so I can combine like terms. So this will become 9x minus 18 plus 11 minus 8x. Okay, great. 9x minus 8x, we'll combine that to an x. Negative 18 plus 11, we'll combine that to be a minus 7. Now we've simplified this bigger equation to one of those first 4 that we looked at. Add over the 7, x equals negative 3. So again, same situation, store negative 3, type in the left-hand side just as you see it, and the calculator better give you a negative 10 for an answer. If it doesn't, something went wrong. Number 14 here, here's a situation where I don't need to do the distributive property. Okay, there's nothing else being added or subtracted to my parentheses, so technically I can undo this multiplication of 3 because there's no adding or subtracting outside of the parentheses. All right, you could distribute it, but you're going to make the numbers bigger. So I'm going to opt to just divide both sides by 3. 3's cancel. 78 goes, 3 goes into 78. Looks like 26 times. So now my numbers are smaller. Subtract over the 8. 9x is equal to 18. We divide by 2. X is equal to 2. Please keep in mind, you would still get the same answer of 2 if you distributed in the 3. Again, store 2 in for x, type in the left side, make sure it's equal to 78. 15, here we have fractions. All right, so 2/3 x plus 7 is equal to negative 5. All right, so x term by itself, let's subtract over the 7. 2/3 x is equal to negative 12. We saw earlier when you have a fraction here, we're not going to divide by 2/3, but we're going to multiply both sides by its reciprocal to cancel those out. And 2 goes into 12 6 times. X is equal to negative 18. All right, 16. We have 1/4 x plus 1/4 is equal to 3. So here, I'm not going to subtract over 1/4 because I don't want to change this whole number here into more fractions. So here's a nice little trick. I didn't do it over here to this one because there's one fraction. But if I have multiple fractions with different denominators, I'm going to show you how you get rid of all denominators. Since this is divide by 5 and divide by 4, then what we're going to do is multiply everything by 5 times 4. So the left side is multiplied by 5 times 4. That's these two denominators. And the right side's multiplied by 5 times 4. Well, 5 times 4 is 20, times 3, that'll be a 60. Now here what's going to happen is when you multiply this into the parentheses, now I have 5 times 4 over 5 times my x, and 5 times 4 over 4. 5's get to cancel, and then the 4's get to cancel. We now have 4x plus 5 is equal to 60. Look, Mom, no fractions. Subtract over the 5. 4x equals 55. We divide by 4. X is equal to 55 over 4. So again, if you wanted to bring your calculator to this problem here, we said 55 over 4. So alpha y equals 55 over 4. We store it for x. Now we got to type this in to see if it's truly equal to 3. So I'm going to type this in as alpha y equals, I'm just going to call it x over 5. I'm just going to multiply the 1 to the x. Perfectly legal. Plus alpha y equals 1 over 4. Alright, if this is right, it's supposed to equal 3. There's my 3. Now remember, it's not going to be 13.75 because that's what my x value is. Type in the left side. If it's equal to the right side, then you know it's correct. Alright, number 17. As you can see, we have now two variables, but they're not on the same side. They're on opposite sides. So again, rule of thumb. 1x is smaller. We're going to move that over to the other side by subtracting the x. So that's now 6x minus 2 is equal to 28. Get rid of the minus 2. We're going to add 2 over. 6x equals 30. Divide by 6. X is equal to 5. So again, store it for 5 in for x. Type in the left side. Type in the right side. They both have to be the same value. 18. Negative 4m plus 12 is equal to negative 8m plus 26. So again, we're going to move the negative 8m because it's smaller than negative 4. So I'm adding that over to the other side. Gives me 4m plus 12 is equal to 28. We'll subtract over the 12. 4m is equal to 16. Divide by 4. X is equal to 4. Store 4 in for x. Type in the left side with an x. Type in this with an x. Both sides are equal to the same value. Then we know 4 is right. 19. 1.2x minus 1.7 is equal to negative 3.62. 1x term is great. Add over the 1.7. If you have to let your calculator do that number crunching, by all means do so. Then we divide by 1.2. Go to the calculator, divide that. X is equal to negative 1.6. So again, store it. Type in the left side. Make sure it equals that. 20. Okay. Can I divide by 9? No. There's a minus 10. So we have to do the distributive property. 9x minus 27 minus 10. Combine these to become a minus 37. Now between 9x and 15x, 9x is smaller, so we're moving it over to the right-hand side. Negative 37 is going to equal 6x minus 55. Remember, x does not always have to be on the left side. That's false. It can be on its either side. It just has to be by itself. So get rid of the minus 55. Add it over to the other side. We're going to get, let's see, positive, looks like 18 equals 6x. We divide by 6. Because we're multiplying by 6, x is equal to 3. Store 3 into your calculator. Type in the left side just as you see it. Type in the right side as you see it. And if the two values are the same, you know you're right. 21, 1/3 times x plus 2 minus 4. So here, okay, there's a minus 4. We should probably distribute, wait a minute, I don't want to distribute fractions. So let's think a little bit outside the box. Let's add the 4 over to the other side. Now, the reason I did that is now there's no adding or subtracting to this. So to get rid of the multiplication of 1/3, you divide by 1/3 or you multiply by its reciprocal, 3 over 1. And now we have x plus 2 equals negative 3. We subtract over the 2. X equals negative 5. And again, store it for x, type in the left-hand side, make sure it's equal to negative 5. 22, no adding or subtracting outside the parentheses, divide the 0.5 to both sides. 1.4x plus 0.98 is equal to now negative 100.52. All right, subtract over the 0.98. 1.4x equals a negative 1.01.5. Divide by 1.4, and again, let your calculator do that kind of number crunching. X equals negative 72.5. Store it for x. Type in the left side, make sure it equals negative 50.26. 23, can't move the minus 3 because I've got multiplication of negative 5. This one, no choice. We're going to have to distribute the negative 7 and distribute the negative 5. Negative 7x minus 42 minus 3 is equal to negative 5x plus 10. There's a sign change there. All right, negative 42 minus 3 is going to be a minus 45. Which variable term is smaller? Negative 7 is smaller than negative 5. Add 7x to both sides, and now this x term over here is positive. We don't have to worry about negatives. Subtract over the 10. Negative 55 is equal to 2x. Divide by 2. X equals negative 55 over 2. Store that for x. Type in the left side as you see it. Type in the right side. If both values on your calculator are the same, then you know you are correct.